All right, let's do 3 more examples of graphing quadratic functions in vertex form. Maybe you can try these 3. Maybe you can pause the video and see if you can figure out the transformations for C, D, and E. Figure out where the vertex is. Figure out if your parabola is going to open up or down. Is it going to be fat or skinny? See if you can find at least 3 ordered pairs points on this parabola so you can sketch the graph. And then make sure that you identify the vertex, the axis of symmetry, if it has a maximum or minimum, and what that maximum or minimum is. Try C, D, and E, and then come back and let's see if we have the same answers. All right, for C, it looks like the leading coefficient is a 1. It's a positive 1, so I know that this parabola is going to open up. It's not a fraction. It's not bigger than 1, so it's not going to be really skinny. It's not going to be really fat. 1's kind of right there in the middle, right? But I know it's a positive 1, so my parabola is going to open up. If it opens up, is it going to have a maximum or a minimum? Well, if it opens up, it's going to have a minimum, right? So I know that at least right now. Let's figure out what the vertex is. I know that the vertex is at h, comma, k. That's the number on the inside and then the number on the outside in the back, right? And so it looks like this is going to shift it to the right 3 and down 5. So my vertex is at the point 3, comma, negative 5. Remember, it's opposite of what's inside of the parenthesis and then always the number in the back. 3, negative 5 is my vertex. So let's go ahead and use that as my middle point, and then let's pick a number just to the left and just to the right, and then find my y values. If I plug in 2 to x, 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 5 is negative 4. If I were to plug in a 4 for x, 4 minus 3 is 1. 1 squared is 1, and 1 minus 5 is also negative 4. Remember, it should be a mirror image, right? And so plotting these 3 points, I have 3, negative 5. I have 2, negative 4. And I have 4, negative 4. So my parabola looks something like this. Not too skinny, not too fat. It's shifted right 3, down 5, and I know that it opens up. It has a vertex at 3, comma, negative 5. It has an axis of symmetry at, remember, x equals 3. That's the same as the x value of the vertex. Because it opens up, I know I have a minimum, and the minimum is y equals negative 5. Remember, that's the y value of my vertex. Did you get the same thing I did? All right, let's look at D. D has a leading coefficient that's a fraction. Ooh, what does that fraction mean about our parabola? Yeah, it should be kind of fat, right? And it's a positive fraction, so I know it's going to open up and be kind of fat. Sometimes books call that a stretch or a compression, a vertical stretch, right? Skinny, or a vertical compression, fat. Okay, the number on the inside and the number in the back, the h and the k, is going to give us our vertex. In this case, the vertex is going to be negative 3, comma 6. That really means I'm going to go left 3 and up 6. If I start with that as my middle point, I can try other points on the left and the right, but be careful. I tried negative 2 and negative 4, and because that leading coefficient was a fraction, it ended up giving me fractions. I think I got 13 over 2 for both those. Now, you can do it, but when we're trying to graph, if we're graphing fractions, we're then estimating and kind of guessing where halvesy is on a graph. And so our graphs aren't going to be as exact. So we might want to pick other values for x that might work out so that we have whole numbers as our y, so we can more accurately graph these. It's a lot easier if I have whole numbers. So I'm going to choose some other numbers instead of negative 2 and negative 4. How about negative 1 and negative 5? If I plug in negative 1 plus 3 is 2. 2 squared is 4. And 4 times 1/2 is 2. 2 plus 6 is 8. You might want to write those steps down so you understand where I got that from. But if you plug in negative 1 for x, you should get 8 for y. So plug in negative 5. Plug in negative 5 for x and see what you get. Negative 5 plus 3 is negative 2. Negative 2 squared is 4. 4 times 1/2 is 2, and 2 plus 6 is 8. Perfect. Nice whole numbers. I have 3 ordered pairs then that I can accurately graph so I have a good idea of what this parabola looks like. I got a point at negative 3, 6. I got a point at negative 1, 8. And I got a point at negative 5, 8. And so my parabola looks something like this. A little fatter than before. I knew that because of the fraction in front. I knew that it opened up because it was positive coefficient. I was left 3 and up 6. My vertex was at negative 3, 6. My axis of symmetry is at x equals negative 3. Because it opens up, I have a minimum at y equals 6. Hopefully you got the same thing on that one. All right, one more. Let's look at E. E has a leading coefficient of negative 2. That means that it's going to open down and be skinny, right? Because it's not a fraction and it's bigger than 1, so opening down and skinny. My vertex is negative 4, negative 3. That's left 4 and down 3. I can go ahead and start with that point and then find some other x values just to the left and just to the right. If I plug in negative 3 plus 4 is 1. 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 minus 3 more is negative 5. I know that I'm doing that in my head. It's probably not a great idea for you. You might want to slow down and write out all those steps so you don't mess up. Another way to double check is it should be equal. If you plug in on the left side, remember the right side should be a mirror image. And so if it's not symmetric, you know you did something wrong. So plug in negative 5 and let's see if it's symmetric. Negative 5 plus 4 is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. And negative 2 minus 3 is negative 5. So perfect. Let's go ahead and graph it. I have negative 3, negative 5. I've got negative 4, negative 3. I've got negative 5, negative 5, negative 5, negative 5. I need to zoom this in a little bit. All right, and so my parabola opens down. It's pretty skinny. Yep, that makes sense. I'm left 4, down 3. My axis of symmetry is at x equals negative 4. Because I open down, I know that I have a maximum on this one, and my maximum value is at y equals negative 3. So as long as my quadratic function is written in vertex form, you should be able to tell me all the different transformations just based off of those three values, the a, the h, and the k. You should be able to tell me lots of things then, the vertex, the axis of symmetry, if it has a maximum or a minimum, and what that maximum or minimum is. And you should be able to graph it using at least 3 points on that graph. Making sure you're comfortable with that so that we can add to it a little bit in the next video. Because what happens if it's not in vertex form?